Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review what was covered in week 5. We were introduced to a new type of sequence called a geometric sequence. So a sequence is geometric if it follows this recursive definition here. This says to get the next term in the sequence, you take the previous term and multiply by some number r, which we call the common ratio. So the terms in a geometric sequence have a common ratio. For example, in this sequence here, if I take any term and divide by the previous term, I always get the same number. I always get the number 2. So what that means is each subsequent term is being multiplied by 2. 2 is the common ratio. So this sequence here is geometric. On the other hand, this sequence here is not geometric. I have to times by 2 to get to the second term, but then I times by 1.5 to get to the third term. I'm not multiplying by the same number each time, so this sequence is not geometric. In fact, it's arithmetic. So geometric sequences always follow this pattern here. We're multiplying by r each time. So from this comes the formula for the nth term of any geometric sequence. So let's say I wanted to find the 20th term of this geometric sequence here. So I have t20 equals a, which is the first term, times r, the common ratio, to the power of n minus 1. So putting that on my calculator, I get this number here. It's actually a big number, 3,670,016. So that often happens with geometric sequences. The terms get big really quickly. They increase exponentially. All right, let's have a look at using this formula here to solve for some of the other things in the formula. So let's look at this question here. So we're told the fifth term of a GP, which is just a geometric progression or geometric sequence, we're told that's 5. The ninth term is 0.008. What are two possible values for the second term? So to find the second term of a GP, I can just use this formula here. The problem is this question didn't tell me what A and R are. So I must first find those two things so I can find the second term. Now, if you're trying to find two variables at once, here A and R, you should think straight away simultaneous equations. We're going to turn this into an equation and this into an equation. Now, the ninth term, T9, of any geometric sequence is always AR to the power of 8. All I did was just change n to 9 here. So we're told in this question that that's equal to 0.008. Similarly, the fifth term of any geometric sequence is always AR to the power of 4, and we're told that that equals 5. Now, to solve these simultaneously, I need to eliminate one of the variables. If I divide one equation by the other, I can get rid of the a's. You always want to have the higher power of r on top so you don't end up with a negative power for r. So a divided by a is just 1. R to the power of 8 divide r to the power of 4, just using index laws is r to the power of 4. And then 0.008 divided by 5 is 0.0016. Now you have to be a bit careful here. When the power is even, there are two solutions. If the power is odd, there's one solution. But here there are two. So on my calculator, I can put the fourth root of 0.0016. My calculator tells me that that equals 0.2. But we have to be aware that there's also the option that it's negative 0.2. Both of these values, if substituted for r here, would give a true statement. Again, there are two possible values for r when the power is even. When the power is odd, only one solution. So after we found r, we need to find a. It turns out in this question, both of these values of r will give the same value of a. So substituting this into this equation here, I would have that a is equal to 5 divided by r to the power of 4. See, 0.2 to the power of 4 and negative 0.2 to the power of 4 both equal that. So putting that on our calculator, A is 3125. So there are two possibilities for this sequence. It could be 3125, and then we're timesing by 0.2 each time, which is the same as dividing by 5. It could go like this. Or what could happen is each second term would be negative. It could be 3125 negative 625, 125 negative 25. They are the two possible sequences we have. So the two possibilities for the second term, either 625 or negative 625. All right, let's do one example now where we're finding n. So let's say we have this geometric sequence here and we want to know which is the first term to exceed 10,000. We're asking, is it the 20th term, the 30th term, whatever? We're actually asked to find n. So we're still going to use the same formula, but this time solving for n. Now, in this question, A is equal to 32. R is equal to 1.5. If you didn't know R, you just take any term, divide the previous term. 48 over 32, 72 over 48, 108 over 72, all equal 1.5, the common ratio. So what we want is we want this, AR to the power of n minus 1, to exceed 10,000. So we're going to start by dividing each side by 32. So now we get 1.5 to the power of n minus 1 is greater than 312.5. The thing we want to find, the unknown, is part of the power. This is an exponential equation. So what you can do is you can graph y equals this, change that to an x, y equals this, and find their point of intersection, or we can use logs. So if I'm using logs, what I get is n minus 1 is greater than log of 312.5 divided by log of 1.5. So I get n minus 1 is greater than 14.17. So remember, that's what logs do. They undo raising to the power. So now I just add 1 to both sides and I get that n is greater than about 15.17. What this means is the 15th term of this sequence would be a little less than 10,000. So the next term, the 16th term, will be the first one that's a little bit above 10,000. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.